Good morning, everyone. On behalf of the organizing team, I extend very warm welcome to our esteemed guests, distinguished panelists, and all the participants to this significant event, Energy Efficiency Audit towards Smarter Consumption. Today, we are gathered in Seminar Hall 9 at the BS Polytechnic, Ganpat University, to discuss a topic of critical importance, making our energy consumption smarter and more efficient. First of all, I request to Sri K.M. Patel sir to give the welcome speech and brief introduction of our distinguished guest and panelist. K.M. Patel sir, please.
Good morning, everybody. A very well welcome to all of you. I am K.M. Patel, Deputy Chief Electrical Inspector and co-anchor of today's seminar. And Mr. A.B. Chaudhary, he is the anchor of today's seminar. We both of you welcome all the delegates. As you know, Gujarat is doing Vibrant Gujarat series since long, and on successful all Vibrant Gujarat series, Government of Gujarat has planned to make regional Vibrant Gujarat series, and this is one of the first Vibrant Gujarat regional series. Subsequently, another regional conference will be held in the next year, 2026. Today's topic is energy efficiency and audit. As we know, energy efficiency. Yes, sir. Yes, sir. I will introduce Ganpat Dada. Big clap for him. It is our great pleasure. દાદા આપણી વચ્ચે આવ્યા. દાદા વિશે એક વાત કહું તો લગભગ 4-5 દિવસ પહેલાં અમે જસ્ટ ઓવરવ્યૂ કરવા કેમ્પસમાં આવ્યા હતા અને એમના કોન્ફરન્સમાં અમે બધા બેઠા હતા અને દાદા આવ્યા. તો દાદાએ જ્યારે બોલવાનું ચાલુ કર્યું ત્યારે સાહેબ મને એવું લાગ્યું કે હવે સાંભળ્યા જ કરીએ. દાદા એટલું સરસ બોલે છે. Sorry, sir, I continue. As we know, energy efficiency, it's a profit without investment. It is just, energy audit is a just smart management, only smart management. I will not take much time. I will, in short, brief the introduction of our today's speakers. Professor Narayan Pindoria sir. Professor Pindoria sir is a professor and head of electrical engineering, IIT Gandhinagar. He is expert in smart grids and renewable energy grid integration. Professor Pindoria drives research in grid optimization and energy management. His innovations in smart energy management support India's transition to a low carbon grid. He also advises Government of Gujarat in Gujarat's energy efficiency technology inventions. Now I will introduce Mr. Rajan Rawal. Sir is a professor and senior advisor at the Center for Advanced Research in Building Science and Energy at SAPT University. He has also He was also the executive director for CARBAC between 2006 to 2021. He is also a member of various technical institutes and Bureau of Energy Efficiency. At present, he teaches, as he is a professor at SAPT University, he teaches energy efficiency, energy built environments, energy policies, energy modeling in the PG and doctorate programs. Professor Rawal led Indo-US Joint Clean Energy R&D Center. Professor Rajan Rawal has been honored with fellow status of American Society of Heating, Refrigeration and Air Conditioning in the year 2020. Now I will introduce Mr. Prakash Vankani. Mr. Vankani is an energy expert, been working in this area of energy conservation and energy efficiency exclusively since last more than 3 decades. He is an accredited energy auditor of BEE, Ministry of Power, and also auditor ISO 5001, lead verifier of GHG accounting, and fellow and chartered engineer, Institute of Engineers. He is the founder of Audit Energy Services. Now I will introduce Mr. Anil Khopkar. Mr. Anil Khopkar is Assistant Director and Head of R&D Division in the ADA, Vadodara. He has wide experience in the field of power system, renewable energy, high voltage systems, and energy audit. He has published more than 40 research papers in the international and national conferences and journals. Our next speaker is Mr. Kirit C. Patel. Mr. Patel has done his graduation from University of Hawaii in 1973. He has done his master in computer science from Cal State University, Long Beach in the year 1982. Mr. Patel has over 3 decades of experience in the continuous advancement and expertise in computers, embedded systems, and IT protective self-starter with track record of initiatives. Our next speaker is Mr. Taylor D. Rose. Mr. Taylor is a serial entrepreneur with over 15 years of experience in applied electromagnetics, digital signal processing, and large-scale impact initiatives across the US and EMEA. He is a chairman of Stray Systems. Most recently, he led the creation of the world's largest demand-side distribution-level power quality database, logging more than 750 megawatt. Our next speaker is Mr. Yash Patel. He is a trained nuclear engineer. Very new subject for us. He is a trained nuclear engineer. Serving as a CEO for Stray Systems, he has been a part of this group for a couple of years. His role is to innovative spectrum of energy solutions from power management to production. With this introduction, I will not take much time as we have many experts to deliver the lecture. Today, I will request Dr. Pandoria sir to be a moderator for this session. Okay, thank you, sir. I hand over to Mr. G.K. Prajapati.
Thank you, Sri K.M. Patel sir, for introduction of our panelist. We are privileged to have such a distinguished group of experts to share their insight with us today. Let's give a big round of applause. Now, let's begin the felicitation ceremony. First, I would like to invite our Chief Electrical Inspector, Sri A.B. Chaudhary sir, to felicitate our moderator and Professor Head of Sri Naran Pindoria sir. Now I request Sri K.M. Patel sir to felicitate Sri Rajan Rawal sir of SEPT University. I would now like to invite Sri S.S. Shah sir to felicitate Sri Prakash Vankani sir. Sri V.C. Patel will now felicitate Dr. Anil Khopkar sir. I would now invite Sri J.D. Chaudhary to felicitate Sri Kirit C. Patel sir. Sri K.R. Makwana felicitate Sri Yash Patel. I request Sri N.B. Shah to felicitate Mr. Tel De Ros. Now I request Sri A.B. Chaudhary sir to felicitate our Sri Ganpat Dada. Please sir. Thank you everyone. We will now move on to the most anticipated part of our event, the keynote speech. I would like to invite Professor and Head of Electrical Engineering Department, IIT Gandhinagar, Sri Naran Pindoria sir, to deliver his keynote address, please.
Very good morning to one and all present here. Uh, so it's my great pleasure to have eminent speaker on dais and very motivated and energetic audience here, and therefore we would like to have this session more interactive. As we know, this topic on energy efficiency, energy audit, and consumer and efforts to maximize the efficiency of energy conversion and transfer to the end user become a sort of need for today. And therefore, I think this session is very much important. And we have eminent speakers with their diverse experience and very well practiced to the ground. I mean, that's how it is very important that how our research knowledge and practice knowledge translate to the society benefit. With that note, we have a sort of panelist coming from uh, energy efficiency, energy audit background, implementation, how to interact with the consumer, consumer awareness, implementation, and that's what we know, that energy efficiency, energy conservation measures, energy efficiency measures are assessed by implementation rate. And therefore, it is very important for us to understand how we really motivate the end users to participate in ECM, EEM activities being supported by BEE at the state level, GEDA and Gujarat Energy Development Agency and CEI office. We have experts from the technical implementation point of view, from the regulation point of view, from the governance point of view, from the finance. As we know, like industry who are very keen to implement, there should be, I would say, right finance available for implementing ECM and EEM, and therefore we have a expert to complement that part also. And we have energy domain experts as well. I come from the technology, so I will also try to present our selected impactful use cases that we realize over a couple of years of our exercise with MSME. But before I present our work, I would now request each and every panelist to briefly highlight the impactful sort of recommendation and their observations about their experience, their expertise center around energy efficiency, conservation, and consumer engagement for driving the energy efficiency. With that note, I would open up now the panel discussion with a brief note by panelist. So I will start with sir, first you, if you could kindly give your sort of brief on energy efficiency, energy conservation level. So the audience would try to understand like what all are the core verticals that we are trying to discuss today, and please make this opportunity and this 1.5 hour session more interactive. Feel free to ask question, and therefore we as a panel decided that instead of having a Q&A towards end, let us be interactive during a session itself and make it this as more informal than the formal, okay? So this is how we are planning. So therefore I am requesting each and every panelist to highlight about the key sort of aspects center around this topic so that all of us can understand whom to interact during this session. Thank you very much. Sir, please.
Thanks, Professor. So let me tell you a couple of things which we thought that would be interested and what energy efficiency can do, or rather what is possible to achieve through efficiency, or what is required to be done. So let me give you a couple of examples. The little bit of work which we did for Ahmedabad Municipal Corporation on how do we really look at the entire city as one unit, and how do you really start saving the energy for at the city level. You might have come across a lot many audits or lot many models which talks about individual building, that if this particular university, if it has to save energy, what it can do for walls, it can do for roofs, also it can do something for air conditioners and lighting. But that's not just a full story. The full story is that not just one building, but multiple buildings. So for example, Ahmedabad has about 6 lakhs buildings, and about multiply by 10, about 60 lakhs properties. Each building will have more than one property. So what is there for each of those people to save energy, and if at all, entire Ahmedabad starts saving energy, how much we will be able to save, how much emission we will be able to reduce. But that's on a plot of a building. How much energy is being used by municipal corporation to supply water to these buildings? How much energy do we use in a transportation outside our own building? How much energy Ahmedabad Municipal Corporation use for street lighting or sewage water? And once you start putting these things together, number becomes more and more. And then you realize that probably what we are doing at our house level, our dwelling unit level, there is a limit by which you can do something. Then onwards, as individuals or as an organization, we do not have anything to do, because the kind of market which we are getting in, we don't get those products. So one side, we will talk about policy at some point in time, as Professor will guide us. And largely, people have a tendency to go for a policy, but speaking in vibrant Gujarat, sitting in somewhere near Ahmedabad, sitting in Gujarat, we simply can't rely on policies to do certain things. Market, we know business much better than anybody else in this country. Market is where probably we need to start thinking about. Let me give you another example of air conditioners. Largely, as I understand, energy auditors are sitting in the audience, and all of them are must be aware about something called star labeling program, 1, 2, 3, 4 star. If you get a 5-star air conditioner, you save more energy. If I compare that air conditioner along with few other appliances or few other electrical gadgets which we use, you will realize that air condition has not progressed since last 100 years. If you look at a refrigeration cycle, what is the efficiency of refrigeration cycle, what we are getting right now? And I'll come to that in a while. But there are two ways by which you can look at what is available in the market and what is available in the R&D or in a university R&D. So for example, if you look at a solar photovoltaic, it has progressed quite well. What you get in a market, probably 22, 23, probably a little higher efficiency. But in the labs, the way people are doing R&D, probably 60% of solar photovoltaic panel efficiency is possible to achieve. That means probably 7 years down the line, 5 years down the line, all that product which is there in the R&D phase will come in the market. So probably things are progressing quite well. If you look at the lighting, LED theoretical efficiency, we have reached about 85%. So 1 watt of electricity, what we are getting about 85% of light. If you look at the air conditioner, you will be surprised that amount of electricity which we are putting, we get just 7% of cooling out of that. And that means that efficiency of air conditioner which we get in the market is just 7%. Theoretically, if you push that limit and start looking at R&D, it can go up to probably another 5%, that means 13%. And why is that so? Somebody made an air conditioner in 1930, and then onwards, efficiency of air conditioner has not changed more than 2.5% over 100 years. Why is that so? There's nothing to do with the technology, it's everything to do with the market. That means only one country makes 75% of compressor across the world. And in that particular country, only 2 companies make. That means if I have to change something, I have to really, it's like a huge inertia. It's huge animal which cannot change its own course even if you start pushing, even if you start using everything. That means that that animal will start eating up other animals as well. That means if somebody is so big and you cannot move that industry, a smaller industry which is trying to do any kind of innovation would be subdued and will not be permitted to move forward because this big guy is sitting somewhere and selling 70% of compressor across the country, across the world. This is where it's not just about R&D, but not just about innovation, but also the market. How do you take 1 or 2 products and bring it to the market? Policy will really help us. Innovation and hubs will help us from government of Gujarat side. But what is required is finally market. So we launched, we call it a we call it a global cooling price competition from our university with a couple of other international organizations, saying that anyone who gives us 80% better air conditioner, we will put 10 lakh air conditioner product order, and cash price would be about 10 crores. This is across the world. And we found over two years, we found two products which are 80% better than what these guys are right now. Now, if in India, you scale this up, just about 25% of air conditioner which are getting sold in India is of this new technology or new approach. Probably you will be able to deal with 0.01 degrees climate change rise. That means we are talking about 1.5 degree rise, 0.5 degree rise. Emissions will suddenly drop the moment you have a better air conditioner coming into the market. So the success story is not in a university, success story is not in R&D. Success is also not a kind of policy which government will put it. Success is always how much money you put it in the market and how much money you will get out of that. So let me stop at that time, and I can elaborate this more and more. But this is what my initial thoughts. Thank you.
Thank you, Professor, for very insightful points. One is how we convert or best leverage municipal waste and make it to wealth. Actually, waste to wealth is very important. That is one part. Second is at the domestic level or otherwise even CNI, commercial and industrial level, the major energy consumption is HVAC. And in India, climate condition is air conditioning. Looking at that air conditioning, how we should really take the opportunity for energy efficiency measures, because air conditioner, while we keep the compressor on a roof or outside, actually throwing the heat energy, right, thermal. So eventually it is also polluting our environment. So if we look at the round cycle system, one or other way, like it is still hampering to the environment and to the climate change. The third one was, sorry, sir. Yeah, please.
I want to tell you a funny story.
Here we go.
I want to tell you a funny story. I'm really surprised that it is only 7%, the air condition efficiency. But I was running a very large business in America, and I had a lot of, almost 500 offices and a lot of engineers. And each one liked their office to be their own temperature. So I made a policy that, okay, we are all going to live with a 26 degrees C. And that's plenty compatible, right? But somebody will put 24, somebody will put 18, and some people didn't like cold, so they will put 30. So I made a policy, nobody followed the policy. What I did was I disconnected everybody's thermostat. and the thermostats were there, okay? Thermostats were there. They all can set up whatever they want to set up. But it was always 26 degrees. And it worked. It worked, believe me. So people, you are right about the policy. Government makes policy and nobody follows. We tell everybody to drive this way and that way, but nobody follows. So first thing to do is India need to become responsible. And how do we do it? You want to save the democracy? You want to give them a freedom? It's a tough nut to crack. Good luck to Modi ji. Thank you.
Thank you, sir. You rightly said, like setting up, thermostat or any other thermal control load. We have to be very much conscious. There should be sort of regulation and policy at a state level and national level, so that the energy conservation would be more aligned, given that it should be, we cannot expect that everyone will follow 26 degree, 27 degree set temperature, but if we regulate through the control itself, that would be the sort of step forward. And I think BEE has recently made a sort of, yeah, please.
No, I will not get into this. Yeah, BE has made 24 degrees centigrade as a default. Nobody follows that. But the notion, what Dada has said, what do we do? Just look at the real estate market or air conditioning market. How do they advertise? They advertise air conditioned buildings, right? Air conditioned malls, air conditioned cars. What are we doing? We are air conditioning cars, we are air conditioning buildings, we are air conditioning malls. Nobody says that I'm giving a comfort to a person. What we should be doing is that we should provide a comfort to a person. If person has come from Chennai, he will require 28, 29 degree, and person who has come from Delhi might require 24, and somebody has come from Ladakh will require 24 or 22. But, as Dada said, everybody is using 24 flat. That means we are also not providing a comfort by even spending a month. Problem is that you are wasting your own money by putting an air conditioner. You're not putting yourself in a comfortable situation. You are cooling the buildings instead of cooling the people. Thanks.
Absolutely. So, very sort of interactive discussion here. Moving forward, I would request Patel sir to highlight the key observations again along the line of the discussion point. Thank you.
I see. Well, I have a slightly different take on this thing because my primary background is in embedded systems design and development and those kind of things. So by definition, the embedded systems themselves are energy efficient.
Right.
And then the user or the customer specifies how he wants to get the energy efficiency implemented. So my background is in the implementation of the energy control systems. And I don't know the composition of the audience here, but if anybody else is, anybody is interested, then we can take it offline later as to how we can do that. Just to give you a couple of brief examples of what I have implemented, I live in the USA as well. In fact, we are in the neighbors with Dada and Manjula Ben, madam. And most of the houses in the United States, mostly middle class and upper middle class, they all have central air conditioning, right? 8 to 10 rooms, and they're all burning energy. So one of the controllers that we have designed is where we put the remote monitoring at the vents where the energy is coming out. And then it automatically programs itself to shut the vent off and on. Because if you can do it manually, but it's very annoying, right? Daytime you are in the kitchen, and at night you are in the bedroom, and so forth. So this one embedded controller was designed with wireless control and a little firmware and software that takes care of it. And you program it once, and then it just manages by itself. You can still override, as Dada said, you can shut somebody's thermostat off and they won't get it. So we had that thing done as well. But bottom line is that I have designed many, many different embedded controllers. And I noticed after coming here that most of the seminars and exhibitions here are all about energy efficiency and energy generation and so forth. So if anybody is interested in that, we can talk more about the implementation aspect of it. That's my background is this. In the last 25 plus years, I have designed over 100 different embedded controllers. Okay.
Perfect. Thanks for that points. I mean, we know that the entire sector, electricity value chain or energy value chain, has been more transforming to digitalization, where IoT, industry IoT, all are having an embedded system. Power management in IoT itself is the thrust area pushing for digitalization. The another one is data centers coming up in a high pace, and we leverage IoT data goes to the cloud or goes to the data centers. Data center become a juggler of the big entity of energy consumption. And we have to start thinking how we can make it more energy efficient, and that's where as we progress digitalization, but at the same time backend is data center, and we have to look at that also aggressively while we looking at the EV charging infrastructure, EV penetration also. So these two verticals, technology transformation towards a consumer end, demand side, play the important role. And as you rightly said, embedded system, IoT devices, we should look at those devices also. Like when we look at the air conditioning here, split AC, right? The set point that we are setting up, let's say 26 degree, the feedback loop is if the room ambient temperature goes up to that set point, then only the compressor installed at the upstairs or maybe along the wall is shutting off actually. But the sensor that you mentioned, that, okay, sensor is right at the air vent, so rather than just the ambient temperature of the room, that sensor will control the compressor. That is what I understand. But I think that typically here, it is based on the ambient temperature. No, not ambient temperature. Room temperature?
Yeah.
Room temperature. Oh, return temperature.
Yes.
But the return heat, I mean the heat temperature would also be like as a function of the room temperature?
Yes.
Indirectly.
Yeah.
But I mean, at least putting a control right at the air vent, maybe even better energy efficient.
It's a little more efficient. This one here was actually controlling the vent itself.
Oh, controlling
Yeah.
the vent
Yes,
itself. Okay.
yeah.
Okay.
And then, of course, the thermostat, wherever it is placed, is the one that monitors
Perfect.
the ambient.
Perfect. So I think these are the important points for a further discussion. Moving forward, I would request, sir, if you could kindly highlight some key activities which would open up a discussion further after this introduction
Yeah, I
round.
think, most interestingly, the 2 points have been discussed. Like one is the air conditioning, the pumping system for the municipal corporation, and also like, some of the other energy conservation measures that one can think of. There are so many policy intervention, but I am coming from a shop floor. I started my career early in 90s, when even getting an appointment of a authority and advocating for the energy conservation, energy efficiency work itself was so challenging. I've seen the entire cycle. One thing I can at this point of time, when Mr. Chaudhary is there, Mr. Patel is there, KM Patel sir, 1999 the government of Gujarat has taken the initiative for the energy conservation, made it a regulatory requirement, a compliance requirement. Even earlier, then the Bureau of Energy Efficiency, which came into the statutory energy auditing for the industries in year 2001. Having seen, because once in every 3 years, the energy auditing has become mandatory. I can say, since I've been involved, I was the first person to get the authorization from the Chief Electrical Inspectorate Office those days. I'm talking of 2000. Mr. Kumri was the Chief Electrical Inspector. And this is probably the 15th cycle, I would say. Okay. And I have seen the transition. Now, in Gujarat, take my words, go to any industry, it has become more and more challenging, something very, very heartening. Because those conventional measures, like power factor improvement, like lighting retrofits, like, HVAC system even, the chillers, efficiency improvements. Now, everything has been done as far as conventional way of looking at energy conservation is considered or managed. So now what is challenging is to come little forward. You look at, the integration of IoT-based systems, like what sir just now said, and with the conventional way of approach. Let me now talk about the, the municipal energy efficiency. In Gujarat, almost 150 ULPs and all of the municipal corporations, I had the privilege of working for the energy efficiency work for them. Even one of the Vadnagar, Narendra Bhai's town, in 2011, they asked me to do one voluntary work for them because they had a lot of issues regarding the supply of water. Some of the zones were not getting the adequate pressure. And the effect was that even in night time, water was to be given. હું ગુજરાતીમાં બોલો ચાલશે ને થોડુંક મને કદાચ સમજાવવામાં, પણ રાતના અમુક લોકોને પાણી આપવું પડતું હતું 11-12 વાગે, which was against the practice of human being. અમે ઘણું કામ કર્યું ત્યાં. Besides the energy conservation, the efficiency improvement with regard to the network and the distribution was achieved. I had an opportunity to make the presentation at the highest level in government, Gujarat, and let me give you the figures. If you look at the entire municipal corporation, if you look at all the ULBs put together, the energy conservation potential, what we had estimated is roughly around 500 to 600 crore rupees. And that is not only the thing. In fact, some in Vadnagar we could find that, the investment is done, but the optimal utilization is not being done. The moment if you are able to use the same, fixed asset which is otherwise, created, the money is spent, and if you do the optimization, there's a huge benefit. Vadnagar કે જે 35,000 વ્યક્તિઓનું એક ટાઉન છે, અને that is where we could do a lot of things. I mean, that was a demonstration project, and with that, a fallout, a MEEP project, Municipal Energy Efficiency Project, was conceived by the government of Gujarat. Again, I had the privilege of doing 10 of the pilot projects. The results are very, very encouraging. As I am saying, now coming to say industries. As I said, the conventional way of energy conservation, almost every industry, particularly in Gujarat, I can vouch, because almost most of the industries I have been able to work. And they have achieved a reasonable, level of energy efficiency, all because of the intervention of government. There are issues like, કે સરકાર આમાં કેમ આગળ આવી? Industries used to tell કે આ તો અમારો benefit છે, શા માટે અમારે complianceમાં જવું? આ basic પ્રશ્નો છે. We have faced those questions. I can just give you one reply. I was traveling to China in one of these 3 energy efficiency country project. Some of the Brazilian friends they shared. કદાચ આપને ખ્યાલ પણ હશે કે બ્રાઝિલ એમાં લગભગ 90% એનર્જી ઇઝ કમિંગ ફ્રોમ ધી હાઇડ્રો એનર્જી, હાઇડ્રો પાવર. અને 2000માં વર્ષ 2000માં બ્રાઝિલ વિટનેસ ફિમાઇન યર, ડ્રોટ કન્ડિશન, પાણી નહીં, અને સરકાર પાસે કોઈ રસ્તો ના રહ્યો, અને તે મેન્ડેટેડ કે દરેક એનર્જી યુઝર, કમર્શિયલ હોય કે રેસિડેન્શિયલ, એમણે કમ્પલસરી 20% એનર્જી સેવિંગ કરવું. સો મચ સો કે અમુક ઇવન એના કનેક્શન વિડ્રો થાય જો ના કરી શકે. સાહેબ, ધીસ ઇઝ ધ ફેક્ટ, અને આઈ ટેલ યુ કે ધીસ ઇઝ વોટ ઇઝ ડુએબલ. એટલું તો આપણી શક્યતા છે જ કે 20% સેવિંગ તો મળે જ, કારણ કે 2021માં સાહેબ જે બ્રાઝિલનો જે જીડીપી ગ્રોથ રેટ હતો એનો એ જ રહ્યો, with a reduced energy consumption of 20% overall for the country. Now these are the glorious examples that our country also look at. And this is what I always advocate, કે ભાઈ તમે કોઈ પણ જગ્યાએ જાઓ. અમે I am working across all the major industries, whether it is Reliance, whether it is United Phosphorus, whether it is Asian Paint, whether it is Nerolax. અને અમારું એસોસિએશન 25 વર્ષથી ઉપરનું છે. હું હંમેશા એમને કહું છું કે છતાં પણ ત્યાં એનર્જી કન્ઝર્વેશનની શક્યતાઓ રહેલી હોય જ છે. Despite the fact they have their own energy cell, but still when you look at those conventional ways, સાહેબે જે કહ્યું કે 26 ડિગ્રી કેમ ના રાખો? Now those are the conventional. I remember, sir, when I was working for the Dubai International Airport, and you will laugh, Emirates-નું આખું ટર્મિનલ અલગ છે અને એશિયનનું ટર્મિનલ અલગ છે. અને સાહેબ માનશો નહીં, અમારું ઓબ્ઝર્વેશન એ હતું કે એમનું આપણા ટર્મિનલ જે આવે એશિયનની ફ્લાઇટો, એનું ટેમ્પરેચર એ લોકોએ સેટ રાખ્યું હતું 23 ડિગ્રી, અને એમિરેટ્સમાં they had kept it 21 ડિગ્રી સેન્ટીગ્રેડ. મેં આ ફંડામેન્ટલ ઇશ્યુ રેઝ કરેલો હાઈએસ્ટ લેવલે કે why don't we do it 23 for all? પણ એના પોતાના પણ કારણો હોય છે કે it was not accepted. So these are the means and ways one can look at energy conservation overall. There are so many technologies are available now. Say like for example સચિવાલય આપણું, હમણાં એમાં પણ મેં અમુક ઘણી કામગીરીઓ કરેલી. એક તમને ખ્યાલ હશે કે ટ્રાઈ જનરેશન શબ્દ છે અત્યારે. So you are talking about generation of power, you are also talking about generation of steam, you are also talking about converting steam into electricity or TR, that tons of refrigeration. આવા ઇનોવેટિવ પ્રોજેક્ટ્સ પણ કરવાની જરૂર છે ભારતે. હમણાં હજી અમારે આ શરૂઆતથી પેનલમાં એ પ્રમાણે જે he was talking about the nuclear energy. Let me put this point, જો તમે પરમિશન આપો.
Sure.
કારણ કે એક તબક્કે જ્યારે ફુકુશીમાનો જે ઇન્સિડન્ટ બનેલો જાપાનમાં, ત્યારે અમારે એનર્જી કન્ઝર્વેશન અને ઇવન ઓવરઓલ વર્લ્ડમાં વાતો એવી હતી કે હવે ન્યુક્લિયરને ન આગળ વધવા દેવું, રાઈટ? એના રેસિડ્યુઅલ અને એના લાઈફ સાયકલ પછીના ઇશ્યુઝ ખૂબ છે. કોઈ કહે કે આપણે ઓર્બિટની બહાર ફેંકી દેશું કચરો ચાલશે પણ અત્યારે નાવ જસ્ટ સી ફનીલી આઈ ડોન્ટ નો મેન ઇફ યુ કેન જસ્ટ ગીવ મી ધ રિપ્લાય આઈ હેવ માય ક્વેશ્ચન કે અચાનક હવે ન્યુક્લિયર ઉપર લોકોનું નજર કેમ જઈ રહી છે ઇવન ગુજરાતમાં પણ આઈ જસ્ટ રેડ કે 4 ઓફ ધી સ્મોલ ન્યુક્લિયર પ્લાન્ટ્સ આર ગોઈંગ ટુ બી કમિંગ ધેટ્સ ઇટ થેન્ક યુ સો મચ
Just to, so just to let you know, the reason why right now there's a huge demand growing, and something that we want to address is the reliability and the scalability of both. And nuclear power is one of the sustainable source of power for multiple years. And something that you mentioned about the waste. So just like in energy efficiency, there has been more energy efficient power plants that are coming up. So traditionally, what they were designing were fuel rod systems, where essentially half of a 1% of uranium was being utilized. So when that happens, you have long-living actinides. So those long-living actinides are the ones that are going for hundreds of thousands of like half-life decay or million-year decays. And those are being currently stored at Yucca Mountain in Nevada. It's a huge deposit. But over time, what we had discovered is molten salt reactors. And all of a sudden, now you have 95% more efficiency. And what does that mean? It's almost 200 to 1 ratio. So now all the actinides are being consumed by the reactions that are being conducted within the reactor. So now all the long-living actinides are being consumed because you're changing them, filtering them. You're getting new heavy elements out of it. You can filter them out. And what you remain with are like about 100 years to 200 years, which are very easily manageable within the current infrastructure that we have. So.
Thank you for.
This is the thing which just other day, last week, one of my friend is in London and he is working in, heavy water there, in nuclear.
Yeah.
So exactly this is what he was trying to explain to me, that first thing he said that India, so far we have not seen any catastrophe of such kind. We are successful in terms of, managing the nuclear plants. That was first point he said.
Yeah.
Second thing, what rightly he said, that, the technological development.
Correct.
So that also.
Yeah, just to add on this, we are well aware about SMR, small modular reactor. And because of the SMR technology, building up nuclear power plant is reasonably faster than equivalent megawatt rated capacity of coal-fired power plant or so. That is one. Because of the technology development, people are now really and seriously thinking over as like all the countries are driving towards decarbonization and adding more and more core power plant, like typical lignite base or indigenous coal, or even blending with the imported coal would not be the way forward. While the coal power plants are sort of completing their life cycle, it is more to replace by either UMPP level projects, each unit of 800 megawatt, or look at the nuclear power plant with safety measures. And I think the earlier sort of psychological or not psychological, I would say, the real emphasis was life safety concern. Now it has been almost taken care, and people are really, government are really pushing forward with the safety measures. If we can keep on adding nuclear-based power plant, and therefore you might have heard yesterday, CMD of NTPC clearly said that they are now pushing, their business vertical is nuclear power in addition to NTPC Green, which they are investing under renewable energy. So Government of India is aggressively pushing nuclear power, and I think the discussion point is very well taken here. Thanks for the discussion here. Yes, sir.
Does everybody knows why data center is going to require lots and lots of power? બધા AI કરો છો ને, AI મફત નથી મળતું. That's where the power goes, because it requires a huge amount of calculations. And today's the chips, the Blackwell chips, require 100 times more power than the previous chips. Okay? So these chips are graphics, the language-based chips, which requires much, much more power. I was in a power business, and there is no other solution except having the modular reactor. So modular reactors are going to be the way of life. And this is why at Ganpati University, we are starting Center of Excellence for nuclear, modular reactor, nuclear power plant education. And also we are starting a center for clean energy. My friend over here, Tyler will talk about that. Tyler, I'd like you to talk about the clean energy and what are the problems with the energy, okay?
Thank you so much. I'm Tyler Thurman, the chairman and one of the co-founders of Stray Systems. We are a U.S. and Indian joint venture company. I should say Bharat.
Yeah, Bharat.
And
Bharat.
yeah,
Bharat. Okay.
yes, very exciting. And so we're doing something unique where we see our entire global society on this electrification trend and digitization trend, right? Which is essentially the widespread deployment of switching power supplies, right? Nonlinear loads, which are also like the Blackwell chips and the GPUs and everything used for data centers, et cetera. And so the load is becoming smart. The next transition is for the grid to become equally as smart. And one of the links between the side effects of a digitized, highly digitized switch modes of power supply or nonlinear load profile and meeting a legacy grid is the introduction of an extreme amount of reactive power, harmonics, circulating ground current loops, essentially what we call electromagnetic leakage. Or we call it, our company name is Stray, so we call those stray losses. Stray losses today, globally, are about 1.1 terawatts, globally. Our total global loading capacity of global, doesn't matter the energy source, global loading capacity is 9 terawatts, roughly. And 1.1 of those are in a category of losses, stray losses, that I just explained to you. All of that, as of today, is considered unavoidable, largely, and essentially acceptable losses because they're within the current standards of compliance. We live in a society today where 5%, 10% means something now for the first time. In the 90s, it didn't mean much. You want to double, right? Now we're in a place where the data centers coming online, more electrification, EV needing to happen, our decarbonization goals needing to be met. That 5 or 10% means a lot. So here at Stray, we focused on a kind of a different approach for how to bring about a next generation technology into the market. And essentially what we've done is we've applied our electromagnetic research over the past 15 years to creating a power quality improvement solution that is able to recover electromagnetic losses for the first time. We're making a partnership here with Guni and with the leaders of our company and advisors to demonstrate this technology at scale for the grid. What this means, in a nutshell, as we begin to commercialize this technology, which we're already starting to do in the US right now, what that's going to mean is your loads are going to get a cleaner, more improved power quality, less harmonics, right? Less reactive power, again, improved power factor, again, less I²R losses. And the second thing that happens is your energy bill on the KVA requirement on your transformer will also be reduced, okay? That'll be a big thing for the customer. And the secondary benefit is the network operators are also going to get the equivalent or reciprocal amount of capacity availability in terms of headroom on these transformers on the grid. So again, if all those numbers right now, we have done about 30 pilot studies. We've just completed our first micro pilots in India over the past month. and continuity across the three continents now we've now deployed on. It's about 11% is where we're at today. So imagine that our network operators, the national grid of India, would have additional 10% available capacity today, right? While the load remains the same, and a higher power quality, which means less maintenance costs for industry, right? And the savings there for businesses. It's significant for the economy, and especially for this market as it continues to grow. We really have to get a good hold on how to intelligently do this, and also, and we're here to help with that, and make partnerships to really apply our technology in the best way with the best partners into the market. And there's a lot we have to learn about the Indian grid and also the market and how we make the right partnerships to do that. And I think there's also a lot of opportunity that we're going to be working on here at GUNI and with the Clean Energy Research Center of Excellence that Dada's putting together here, which we're very happy to be a part of. There is a lot of things we can do in terms of supporting next generation codes and standards for more efficient grounding systems. We've sampled a lot of infrastructure in India already, kind of in stealth, and there's serious grounding issues, both on the production, on the DC side for renewables, as well as on the AC demand side as well. And so it's a global phenomenon too. It's not just happening here in India. It's global. And again, we're here because we want to actually distribute and manufacture our technology out of India and export it, not only domestically, but export it to the world and help really lead the next generation of energy efficiency with a technology that we believe is going to become as normal as power factor correction, and everyone around the world knows what that is. This is something a little different. We call it a parallel passive field effect converter. Sorry, it's very, very technical, but it will be the new FET. It will be the FEC. And so yeah, our first product we've applied it to is something that goes into your sub panel at the distribution level and does it, what I've just told you what it does. And next thing will be other technologies such as transformers and et cetera. So we're very excited about that. And again, we feel like this is our solution is agnostic to the source, whether it's SMR, which we also have a nuclear division of our company as well too. We don't really care what the source mix is, and we really don't mind what the customer is doing. If we can improve power quality and increase the headroom and reduce the losses by 10% across the entire demand side and supply side grid, that's a fantastic place to get that under control as we then continue to build and develop.
Perfect. So what I understand, like it's a product which fit into the distribution panel right after the distribution transformer at the industry, which will take care of harmonics, majorly current harmonics, reactive power compensation, so that power factor improves and get rid of the capacitor bank, maybe active filter here or active compensation.
Let me clarify. So we're all familiar, I don't mean to interrupt you, but we're all familiar with active filters, passive filters. Okay. We are a next generation of called the passive parallel system. And essentially what it means is your load wants a certain amount of amps. Obviously, we all know that. No one's going to change that. What we want to do is we want to, while delivering that amount of kilowatts or amps to your load, we want to reduce the KVA demand on the upstream network. That's what we wanted to reduce. We want to get those numbers closer together. Without saying too much, we've even tested here at GUNI 40% losses, higher KVA than the actual kilowatt consumption. That's significant. Imagine what that means for the global grid. That's a problem. And so that's what we reduce that KVA by 10, 15%. While the kilowatt stays the same. So yes,
Perfect.
Thank you.
I think we'll have a discussion maybe offline, but it is interesting product, and I think because we do not have as such like harmonics regulation today, I believe, and I think people may correct. Maharashtra started. Gujarat we do not have. We have a power factor correction. We have to maintain a power factor 0.852 or 0.9, whatever may be. But there is a regulation, but we do not have a regulation, and it's the best time to have a regulation imposed on a harmonics given the fact that our most of the loads are non-linear, meaning power electronics driven, whether mobile charger, it's an adapter, it's a rectifier, you connect three-phase or single-phase and rectifier. So it's a diode, rectifier. Diode is a non-linear device. Similarly, most of our gadgets are operating on a DC power supply. It's just that we have AC power, so all the way we convert AC to DC, and that's bring the non-linearity. So which means we are introducing current harmonics into the upstream, and that's where the regulation should be. But cutting the long story short, I would now request Dr. Anil to share his thoughts around energy efficiency and conservation. Thank you.
Yeah, thank you, sir. See, ERDA is involved in the energy management and energy audit since 2000. So we have very wide range of expertise of over 25 years. There are n number of case studies are there. Let me share you one simple case study. So this case study was based on the power station. So where there was 6 motors were connected for the centrifugal for the blower. Each motor rating was 2000 kilowatt consumption, power consumption was there, and the rating was 11 kV. Now when we measured the input voltage of the motor, it was nearly 10.6 kV. So all the motor average, and the average power consumption was nearly 2000 and some plus minus. So then there was 6 motors, such motors were there. Then we suggested that we should go for the 11 kV rated, then we should maintain nearly 11 kV voltage. So when we maintain the 11 kV voltage with the use of CFD, the VFD, variable frequency drives, so then when we maintain the voltage, then we see that the power consumption of little bit increased, but the flow was beyond the requirement. So then we stopped one of the motor. So now the total power consumption was 5 multiplied by 2000. So that way the power consumption was reduced drastically. And when we converted into the energy efficient or energy saving per year, it was in terms of 1.130 crores, 1.3 crores. But the investment was only 30 lakhs. So there are many such cases are there where we need very few investment we required, and then we can save the very high amount of the cost. So that is the efficiency of that is the power of the energy management. So we should always go for the energy audit, and we should see where we can save the energy. We have seen the example of the ACs, but there are many products like a transformer. Now distribution transformer is there, which the utilities are using, even MSMEs are using the distribution transformers. Now as per IS 1180, they have given the energy level, as per the Bureau of Energy Efficiency level, energy level 1, 2 and 3. Similarly, they have given the star rating 3, 4 and 5. So if you see the difference between the star rating 3 and star rating 5, there is a huge difference in the losses. So if we use the distribution transformer in the 5-star rating, then we can save the energy. So that is also further ideas is there where we can save the energy. Further, we should, sometimes we install the equipment and then we do not take care of or we do not maintain the equipments like a solar panel. Now everywhere we are using the solar panels, but after installation we don't take care of the solar panel. So if we see or maintain the solar panel or cleaning the solar panel, then definitely we can increase the efficiency of the solar panel and we can get the more output from the solar panels. Similarly, the distribution transformer is also like that. If we see the failure rates of the equipments, I will give the example of only the distribution transformer. In our country, our distribution transformer failure rate is 10%, or in some of the states it is more than 10%, nearly 15%. Whereas if we see the developed countries outside India, there in the European country, there the failure rate is only 1 or 2%. Why it is so? Because they maintain the distribution transformers, they monitor what is the loading of the distribution transformer, and if there is a maintenance is required, they maintain the distribution transformer. Further, if we see the R&D, lots of things sir has told about the R&D. So in India, there is unfortunate things that we are not focusing much on the R&D. If we see the total funding of the R&D, if any MSME or any industries are there, then out of their revenue, they spend only 5%, maximum 5% they spend on the R&D. But in general, they spend only 1 or 2% on the R&D. Whereas in the developed country, if you see the fundings of the R&D, it is more than 30% they are spending on the R&D. So we should also focus on the R&D. Definitely it will pay back after some times. So we should focus on the R&D, we should focus on the condition monitoring, we should focus on the energy efficiency level of the distribution transformer. Sir has rightly told about the IT centers. So IT centers, their data centers, they are using the all the electronic equipment. We should monitor the harmonious contents also. There is a, in the regulation, there is no regulation, sir has told, but there is a limit is 3%. So we should also see whether the harmonious contents are within 3% or not. If it is beyond that, we should take the corrective actions to reduce the harmonics. So that's all from my side. Thank you.
Thank you. Thank you for the insights. You said that the DTR, distribution transformer failure rate. I think for a distribution company, DTR is the key assets, and that's where the most of the total asset value goes, right? The DTR performance and performance monitoring and asset life improvement is the one of the key areas that most of the discoms are looking at to certainly improve their financial health in the retail business in India. And we have now data analytics tools, right? We have a data-driven asset monitoring, asset performance monitoring, and that's how the predictive asset management is the core area that people work on. Moving forward, we all understood now how the energy efficiency in covering the multiple segments from the different angle. I think it's a multidimensional problem, and all of us to work together with a one clear objective that how we improve energy efficiency in our ecosystem and we better optimize the energy resources. With this understanding, I think sir has also mentioned about R&D and I, and that's where I would like to really present very quickly about how industry academic, I come from academic, so how industry academic collaborate for impactful outcome to the industries. I would like to quickly present some of the key use cases that we come across based on our industry relevant project. Could you kindly put the presentation on? Yeah, so we closely work with MSMEs in Gujarat and up to certain extent with Rajasthan. Our project is on energy. We are helping MSMEs on energy assessment study and sustainability study. We have a core team comprising BE certified energy auditor, GHG verifier, and field engineers coming from electrical background, mechanical background or so, given the fact that the industry has a multi-energy requirement, right? Electrical energy, their feedstock could be oil, gas, coal or so, and thermal energy loss, right? Major ECMs are electrical energy loss, thermal energy loss, and chemical energy loss. Given that fact, we thought of let's come together and work with the industry. So we have a, it's not just IIT Gandhinagar. We are doing this pan IIT, and it's fully funded by Kotak Mahindra Bank. I mean, you may surprise that why bank is interested to invest a CSR fund for implementing energy efficiency measures and doing the sustainability study. This really motivates, other than the banking sector, like core energy industries should really look for CSR into bringing consumers on board in energy efficiency measures. So we are doing this, and we are very thankful for Kotak Mahindra Bank to help us with a CSR fund to drive this effort actually. And I would be very happy to share that what we have done so far. We started this project in May 2022. Within a 3 years plus, we could able to achieve up to this. We have covered very unique cluster. Gujarat is place, very unique place, right? We have a ceramic, we have a diamond, we have a pharmaceutical, we have a chemical industries, which are unique clusters. We never find this other than Gujarat state, right? And that's how we bring sort of value addition to this cluster. We have covered 28 clusters, 94 plus industries we have approached, and our findings are very, very appreciable to the industry in terms of the payback period, in terms of the technology intervention. And that's where I find industry and academia should work together and help industry for a better energy management and help them driving towards decarbonization in industry. So very short, we are doing thorough assessment with our sophisticated instruments worth of around 60 lakhs. We have multiple power quality analyzer, thermal gun, flue gas analysis, all sort of equipment. And we really do we do the thorough investigation here, And I'm trying to minimize the time here, optimize the time here. So I will quickly run through some of the key instruments that we have, and we would be happy to discuss in a detail. We have an energy audit team right here, and we will share our brochure with you who all are interested, where all the details are highlighted. And I would be very happy to interact after the discussion. So I would like to present very key use cases here, and I think important use cases. We all talk about water and energy nexus is very critical, and therefore we have a CETPs, right? Common effluent treatment plant. We have two plants, one in Vatwa GIDC, other one is Naroda, third one, bigger one in Ankleshwar. CETP is the core infrastructure where we should optimize energy as much as possible. And that's where we all know we have a dissolved oxygen sensor, DO sensor, and how optimally we should place to have a better water quality outcome, right? So here is the use case, and you can see before the case, I mean business as usual, and after the implementation, how much energy saving here. And the payback period, everything I have mentioned. Some of the use cases we have depicted in our booklet, but we will free to discuss this because of the time constraint. Other one is Himatnagar is full of cold storages, right? Himatnagar is famous for potatoes. And you know all the cold storages, how much degree temperature required, right? Throughout from the top stack to the bottom stack. And the height of what? More than 15 meter, 4th floor, right? Now you see if you keep the temperature -1 degree at the top where the air circulation start, do we maintain the same temperature at the bottom stack where the potatoes are there? You can see the figure here, potato stacks are there, right? And therefore, thermal energy management within the cold storage is very important, which means we have to continuously regulate the compressor feeding the chilled air inside the compressor. And that cannot be done without regulating the compressor speed. And therefore, we should leverage the benefit of VFD rather than changing the pulley. If I have a potato, pulley size would be like this. If I have other than potato, I should change the pulley size. Not that. The second thing our observation was most of the industries always very much conscious about capex. So always try to reduce the capex, but ended up paying more in OPEX. And that is the example I noticed, and this is off the record, I noticed that the motors used here, induction motor used, are the second level motor, meaning most of the motors that I noticed personally are from the Alang wala jo, so it is rugged, it's very rugged and it can work in a harsh environment, but those are not I3 standard, which means I cannot configure my VFD with this. Even if I go with Siemens, ABB, any company VFD, it cannot be configured. So the practices that I have mentioned here, but this is what the nutshell in the story. The second one is pulp and paper industry. Gujarat is very much into this, right? While we are saying Atmanirbhar, which means we have to improve our manufacturing capability. And that's where we have to take it this. Here is the scenario, if you see the primary air pump and all. I mean, the block diagram is given. I will not take much time, but just ACC, specific energy consumption, if you see kg per kg of the coal, after the energy audit and intervention, how much energy, specific energy consumption has reduced, and the payback period, if you see, is just a 0.8 month. Within a month, the consumer or the client will able to recover the investment. I think this is very promising, and this can be only possible if you deep dive into the plant, understand the entire process cycle. And we always expect that the plant should operate at the rated capacity so that our efficiency assessment, energy assessment would be very much up to the mark. The other one is textile. Gujarat is known for that. Ahmedabad, right? We know. And even Uttar Gujarat. So textile industry, again, if you see the major energy consumption in terms of the thermal energy loss and the rolling speed, the speed of the entire belt and so on and so forth. Again, the observation is 29% of the energy saving. This is specific energy saving, right? So what I'm trying to highlight is we have multiple use cases. Laminate industry, Gandhidham is full of laminate, we know, and we should certainly target these unique clusters, help them, make them aware that why energy efficiency improvement is very important so that their OPEX will be minimized. CapEx, they are very conscious, but OPEX also we should minimize. So with this note, I would close my session because of interest of time. But the clear understanding is like we know energy efficiency, energy conservation, having a multiple verticals, multidimensional problem, and that cannot be resolved without we come together. And we have to join a hand, industry, academia, researcher, practitioner, government agencies, and put our all collective efforts to improve the entire ecosystem. The second part, I'm very much happy to note that Ganpat University is starting center on clean energy. And therefore, it is really important, we as an academia, if you do not thrive that knowledge, do not inculcate that knowledge to our student, young generation, I think the effort would not be sustainable, which means we have to inculcate that knowledge even starting from the school. We are discussing with one of the industry who are putting NGO, who is very much keen to make that awareness program to school-going kids, remote areas. We personally travel towards those remote schools and try to inculcate their knowledge, starting with just energy conservation. Bulb ko band kar dena hai, tubelight ko kaise karna hai, ye वगैरह, right? So this knowledge has been very important. Our generation, next generation, and next generation, we should certainly try to inculcate. And thank you, Guni, for taking this initiative. It's very important, and academia can do best because they have a huge strength, 1,000+ students working in this. Even 10% of the student ignites towards this. Our objective is set. I think this is very important, and industry bring the problem statement. Student is a mass can come up with the technology intervention, and that's how the indigenous technology can come up, right? And we can build our patent, we can build our technology, and technology can translate to the industry. Industry provide the test bed for implementation of this. With this note, I think we are now take up some of the quick questions. Not quick question, I mean more like a deliberation, not question. Let's do that. You talk about nuclear energy. Is that good enough, or you would like to? Or we can take up some questions, and that's how the interaction starts. Maybe very brief because of respecting the time here. We have 15 minutes, and we would like to utilize that 15 minutes more optimistically or optimization way as we talk about energy optimization. Okay?
Oh, sure.
Efficient, right?
Hi, everyone. Yash Patel over here. I'm the CEO of Stray Systems, along with my partner and co-founder, Tyler. One of the things that, so we are a US-based company. We have been working diligently in stealth for past couple of years. And one of the things, something that I developed was an AMR, an adaptive modular reactor. And it uses the lifter technology, LFTR, which is a liquid fluoride thorium reactor, where we're using thorium. So to address your question earlier about the safety, that is thorium. It's non-weaponizable, and it has a long lifetime for about 12 years in a reactor compared to about 6 to 18 months of decommissioning a reactor to go through the maintenance and OPEX. Something that we are coupled with is our power systems, and what we have unlocked is efficiency on the power side, where alone in India, we can unlock about 8 gigawatts just on the power assets that we have created so far. Capacity increase. That means we are at Stray, what we have developed is the technology that is addressable today, implemented, and as we scale up, with the modular reactor that we have, it puts Bharat in a unique position for scalability, because on the global consumption, you can see there's a 2.3% of global energy consumption that increases per year. India has about 5 to 6% of that. And that is directly proportional to current India's growth, which is the 4th largest economy as of now. So in order to maintain that and sustain that, energy is a big asset. And that is something that we bring. And we are very happy that Guni has taken such deep initiative, and we're very grateful that we are going in that route of power quality, as well as sustaining and sustainability of power in green initiatives. Thank you.
Thanks for your inputs here. I mean, clean energy infrastructure, where the nuclear is one of the important sector, and infrastructures with what this company is really working on. is appreciable. I think let's open the forum and start the discussion. Now all of us know sort of the strength and work that we have done. Please feel free to ask question, and let's take this opportunity open for that. Thank you.
Good questions. Good questions. Somebody's got a question.
Yes, we have eminent speaker and expert of the various subjects. So don't hesitate. Ask, and if you want to ask anything, you can ask.
Okay, I mean, all of us are comfortable in Gujarati. I would happy to play a role of translator in addition to moderator. So no problem.
I'm still learning.
To ask in Gujarati also. We all are comfortable in Gujarati. Yes. Perfect. Yeah. So as a panelist, as a moderator, as a translator, whichever capacity, whichever role that you think I should play, I will play. We all will play. Rather. Please feel free in Gujarati question, no problem. Please be interactive. We kept 20 minutes, 25 minutes for this.
યસ મારો પહેલો ક્વેશ્ચન છે કે હવે આપણે ન્યુક્લિયર પાવર પ્લાન્ટ તરફ જઈ રહ્યા છીએ તો હજુ સુધી ન્યુક્લિયર પાવર પ્લાન્ટ નવા કોઈ ઇન્ડિયામાં આવ્યા નથી તો માય ફર્સ્ટ ક્વેશ્ચન ઇઝ કે વોટ વિલ બી ધ ગેસ્ટેશન પીરિયડ ફોર ન્યુક્લિયર પાવર પ્લાન્ટ.
Excellent question. So, so we are going through our final validation and a digital twin development for our reactor. So in the pipeline, about 3 years, it should be matured, and that will be the gas station from starting point. Oh, okay. Once you start the build, it's actually modular design, so it's a factory based. So our goal is to have a factory design કે જ્યારે એક રિએક્ટર દરરોજનું બનશે અને हम लोग का જ્યાં જઈશું ત્યાં શિપ કરી દઈશું.
Even in US, just yesterday it was in the news that they think that between 3 to 5 years they're going to have a modular nuclear reactor and they're going to manufacture in a large volume. And they're going to ship it to the site and they're going to assemble at the site. So once it takes off, the price is going to drop and it's going to be the cheapest and the most reliable way to get the energy. When somebody said about Brazil, I know, I've been to Iguazu Fall. All of that energy comes from one big fall called Iguazu Fall. And that Iguazu Fall is giving all the energy to not only Brazil, but Argentina also. They both share. It's Iguazu Fall exactly halfway between both countries. One of the things I wanted to tell you was that continue doing the research. Typically, Gujarati mindset is instant gratification. You know what instant gratification means? Gujarati એવો ધંધો કરશે કે જેમાં ચોખ્ખો તરત પ્રોફિટ દેખાય. કોઈ રિસ્ક વિસ્કની વાત નહીં. જમીનનો ધંધો, જમીનનો કોઈ રિસ્ક નથી, ભાવ જ છે, પૈસા બની જશે, right? So, but if you do research, you could hit big. You could hit the jackpot in English. When I started my business, for 3 years almost, Dadi did not go to shopping. We were hand to mouth. We had no money. We really, we were hurting. ત્યાં તો અમારું કોઈ હતું જ નહીં અમેરિકામાં. અને અમને એમ નહોતું કે થશે. My power supply will be, successful. But once it took off, I had so much demand and, the rest is the history. But so in Gujarat, we need research. You're right. Professor here said that, diamond no business karse. All of those business, there is the sure thing, but there is no IP. There is no IP. You know what IP is? Intellectual property. ગુજરાતમાં કોઈ આઈપી છે જ નહીં. કોપી ચોરી. રિસર્ચ ઝીરો, રાઈટ? કારણ કે રિસર્ચમાં મગજ જોઈએ. The other thing is, when Narendra Bhai said Swachh Bharat, at Ganpati University, we believe in character first, right? Student first and character must. So So we should have a highest ethics. If you have that, you will do well. Believe me, you will do well. So if you do a partnership, be honest to each other. Most of the business starts with partnership and they fall out with a partnership. ઝઘડો થાય છે શરૂ થાય પહેલાં તો શરૂ થાય પહેલાં જો લગ્નમાં એવું જ હોય છે ઘણી વખત પણ so when you do a partnership, be careful that you are looking out for each other's interest and do it with a partner like-minded. So suppose I am expert on one thing, I find somebody who I am my weakness. I had an American partner, my weakness was at that time was my communication. So he was my communication expert and I was a technology guy. So that's how you do things. A lot of things in business is the common sense. Life itself is a common sense. Thank you. This is a great, I like what we are doing here. In Gujarat, we need to do more of that. કારણ કે જમીનોના ભાવ તો હવે આસમાને પહોંચી ગયા છે. કોઈ ફેક્ટરી બેક્ટરી થાય એવી છે નહીં. હવામાં કરવી પડશે. બધા પોલિટિશિયનો લઈ લઈને બેસી ગયા છે. અને સૌથી મોટામાં મોટા નિયમો તોડતા હોય તો પોલિટિશિયનો જ તોડે છે. એમના ઘેરે 24 ડિગ્રી રાખે છે. એમની કારમાં 24 ડિગ્રી રાખે છે. એમના પીએ 24 ડિગ્રી. એમનો પટાવાળો 24 ડિગ્રી. Let me tell you, I think they need to be shape up. And I'm going to talk to Narendra Bhai about that let's charity begins at home. આપણે બધાને કહીએ છીએ કે સારા થાવ સારા થાવ અને પહેલાં તમે સારા થાવ ને આખી દુનિયાને ક્યાં કરો છો. So I think we need to start with the politicians. Responsible citizenship is a way to go. Otherwise, democracy does not last. Democracy, you cannot take it for granted. Thank you.
If I could add something, innovation is so important to keep innovating. Everything has not been discovered already. There is so much more to discover, and we're listening to advisors and elders of ours, such as this man, who's telling us exactly the markets to look at next. Power conversion is going to be big, DC-DC, AC-DC, etc., and also power quality. When we look at the entire energy transition, right, and we start from LEDs, right, and then we saw what that's done to the world, right, and then we look at variable frequency drives, we see what that did, and then solar and wind now, right, and all these technologies are now kind of in their saturation point. Batteries are the next big thing, finally, because we cannot offset. We can't make the sun shine at nighttime. We haven't figured out how to do that yet, right? So, batteries are going to be big. And honestly, between batteries and, which is funny, you talk about the CapEx avoidance. No one wants to spend the money, right? But it's necessary. And SMR, we don't really see anything in between these two things other than power quality improvement. That's the only thing that opens up capacity. And just wanted to say there's so much innovation to be done. And us as a U.S. company coming to India, we can go to China. We can go everywhere. But we're making a bet that ethically and just the timing of what's happening globally and the talent that is here, with the right partnership framework, we can do something very innovative and long-term together, and we can really let the technology innovation lead the way and really do something really special and really big. And so we're doubling down on our position here, and we're really excited. So I love to see someone like Dara speak so frank and honest about the realities we have to deal with in business as well. Because intellectual property is a very sensitive thing to navigate when you're trying to do international business while you're innovating and while you're having to educate PhDs and different institutions on what you're doing and how do you navigate the education open source component of it while also having a proprietary component of it. So I think there's so much of a rich discussion to have here beyond even just the practitioner and installation and maintenance and monitoring and that whole side of it, there's really a lot. And we're excited to I guess, participate in more vibrant conferences and activities here at GUNY and the other universities, hopefully, and just participate in any way that we're welcome to do so. You have a lot of great equipment there, so I could take a look at that too.
Okay. I think because of interest of time, we can take up one question that you have been raising hands, so please. And rest of the questions we can take offline because of time constraints, but we would be, all will be around.
Good afternoon, sir. I am Vikas Uja from GIPCL, and we are working with power industries. I am working with 100 megawatt power plant, solar base, at Raga national level. Sir, the basic question is which kind of energy conservation or energy audit kind of actions we can took forward for these solar plants, because solar panels and solar inverters which are having limited efficiencies, and as per the OEMs, the efficiency of the panel as well as inverter is going to decrease by year. So after 10 years or 15 years, the revenue which is I am consuming today, I will not get after 10 years. And the O&M cost or the unit rate provided by government, it is too competitive. So how we can increase our efficiency rather than other thing, O&M and that things, sir. And we are rigorously increasing in Khavda and Raganes and that all areas which are highly saline.
Sir, as far as the solar plant is we can consider, then I already told you should monitor the condition. Thermography is one of the tests, not only the energy management, but you should do the thermography, where if there is any of the cell is short circuited, you will get the clear cut idea about the condition of the solar panel, and then you can decide whether you should replace that or not. And secondly, you should monitor the dust particles and all. So cleaning normally everybody is doing regularly, but this thermography also you should do it on regular basis.
Sir, that we are doing half yearly, drone thermography, basically, and we are doing, removing the string outages from there, as well as the blind spots or the black spots which are occurring on the modules. But how?
What about the PV curves?
That we are doing on every yearly basis, but how can we, because we are running robots on every evening or morning basis, but because of the weight of the robot, there may be possibility of micro cracks.
Yeah.
So how can we identify that micro cracks from that module, sir?
Yeah, that is.
Is there any technology, or we can identify as early as possible, so we can remove that modules?
So there are two types of intervention. One is what we try to minimize the hotspot or identify the hotspots at the earliest possible, what sir said. The second is at the inverter level, real-time monitoring on the DC side and AC side. If DC side, if the solar PV string itself, because string level, right? If string is not following MPPT, which means something is to be taken care at the string level itself before you look at the AC side parameter. Now, most of the inverters are configured for AC side monitoring. But as a OEM, or as a plant operator, adding one IoT on monitoring PV, PDC, VDC and IDC, and develop a PV curve looking at the the solar irradiance and the ambient temperature or module temperature, you know where my PV curves will lie, and you look at VMPPT and IMPPT, that will give you PMPPT.
That IV curve.
IV curve, right? That to DC side, not AC side. So that you know how my strings are operating.
I think his question is like, how do you do it at site level? I think his question is about like doing it practically on the spot.
That is possible, sir. That is possible at site level.
Instruments and like you are talking about the snail crack. Now, is it possible to identify a snail crack on a PV panel?
Yeah, that is that can be identified from this drone thermography actually.
From thermography, we can.
Thermography will not allow you to know if there is any snail crack. I'm sure.
Snail trail we can also identify by visual identifiers, because
Visualization is not possible.
because we have Varimec, sorry to say that, OEM at our Baroda plant. We have installed one 50 kilowatt rooftop solar, but on that modules, after 2 years of operation, we got snail trails. and that was the issue of EV seats, basically.
Gadgets available which can, allow me to know what if there are any snail cracks in the panel.
Snail cracks are not possible, sir. Snail cracks are not possible.
So that's what he is.
Can I ask you a question? What, and I'm going to interrupt you. What company are you with? What company?
I am with GIP, sir, Gujarat Industries Power Company Limited.
It's a big company.
Yeah.
So, can I make an announcement? We actually just applied our technology. We're releasing a product soon, our first DC side application of recovery of DC electromagnetic leakage. And we've been able to recover 5% on the supply side, which could be reintroduced into the MPPT. Yeah. So while you have these other issues and cleaning and these other issues happening, and we know degradation over the lifetime of the project, we can compensate by recovering the losses that you're factoring in. They actually become recoverable inversely over time as well. And so that's something we're going to be releasing some white papers on with Guni, and that will be available next year as a commercial product.
That is good option.
Yes, sir.
And in solar, loss covering is the generation actually.
So there is one daunting question even I have after 35 years of my career. And one of the barriers which I thought would come from the audience and it should be discussed, and that is the financial constraint. You may come out with energy conservation projects, you may even structure it so properly with MNV protocol to back, but then when it comes to financing, so do we have any such,
Well, it's all about ROI, right? And one thing that is double-edged sword with technology is that it constantly improves. So, for example, your inverter design might be inefficient because it was designed 2-3 years ago or whatever, right? Now you look at it today, and then you look at the ROI and see if you can redesign that inverter, and then by large it can be there. But it's all about ROI, right? So that's one thing. The good thing about the embedded technology is that it constantly monitors the improvement and the efficiency. Like Naranji had mentioned about the air conditioners and those kind of things, right? So we try to do something about it. But bottom line is, you look at the technology constantly improves. That's the fundamental thing. And you have to be at the leading edge to implement. Yes.
Let me elaborate further. My question is to, the panelists also and everyone of us, let me deliberate. Because now with PAT scheme of BE, perform, achieve and pray. And there are so many other, schemes which are coming in, like RCO compliance, we talk about CCTS. And all the documentation are being done so properly. Targets are being given, the targets are all ascertained also. When it comes to implementation, the issues regarding, the priorities, regarding the funding, those are the major issues. Particularly the MSME, they face this kind of challenges much more. Even let me go and take a liberty to say, can there not be a common fund created to help MSME? When we are in such a conference, when the chief electrical inspector has taken the lead, one humble suggestion: can there be such kind of fund be made available, a rotating kind of a fund, which can really help the SMEs? Because for SMEs that is the biggest challenge, funding. Technology, let me tell you, is not a major issue.
So, Prakashji, Bureau of Energy Efficiency has EC fund, and the source of EC fund is also coal cess. But each state can receive up to 4 crore of EC fund for any kind of energy conservation measures which they want to implement. The SDA is responsible for that. The trick is that how do you connect SDA with MSME or the department which is working on that. But I think my understanding with the state government and with the federal government, a lot of money available for many things, probably people don't really use them properly.
I think the other one is awareness, the fund availability awareness. Yet MSMEs have a fund, but somehow that information is not properly. And that's where we play the important role.
No, that's an institutional problem.
See, See, I have led one of this UK-based MNC as a technical director. My ambition was to implement such ESCO projects, energy service company, based on the energy performance contracting. Let me tell you, I traveled a lot, like in US, to understand what ESCO business would all mean. Also tried to look at the Chinese model. We also tried to make a model which is, in context of our country. But when it came to, implementation of such ESCO projects within the government, we face a huge challenge. I did the first energy service agreement with one of the municipal corporations in Gujarat. That was the first in India. It was in the year 2003. Never came onto the floor. The reason was all practical, the financing, the funding, the MNV protocol, bureaucracy, everything put together. But when I did it for a industry, biodiesel manufacturing companies in Chennai and even in ITC food, where I did an innovative way of taking over all of their utilities on a lease basis, 7 years of lease, and only based on the KPIs.
We have now the Haidar sir is coming here.
So, sir, I was talking about, energy performance contracting, and particularly the barrier that, the SMEs face with regard to the financing. So, the EPC or the ESCO could be one of the tools. I was sharing one of my experiences in industry as well as in government. So, this is what we were discussing. In industries, I tell you that an innovative model like, taking over all of their utilities for a long lease period, 7 years, say for example, KPIs are drawn. The contract is such, designed where, the ESCO company either will get penalized also if they are not able to deliver. And at the same time, a committed output is given at a certain predefined rate, which is a very, very successful model. Now, my only thing is why those kind of projects are not being pushed in numbers. In government, sir, with all due respect, I was the person who did the ESA agreement, the Energy Service Agreement, for the Jamnagar Municipal Corporation early in 2003. But that never came to the floor. Despite almost everything was done, but only again for the reason that financing. So the major point that I was trying to dwell upon is what do we can do for the funding. One of the suggestion is that can some rotating fund be made available under the climate change department? Can it be, can it help the SMEs so that the real implementation of such energy efficiency projects can take up? That was
My understanding with most of the ESCO there's nothing wrong with the technical feasibility. It's just a mistrust between two players, and hence when the contracting is taking place, I would say probably we don't have enough legal support to make sure that contracts are in place where both party agrees to it and brings a trust. I think there's nothing wrong with the ESCO model. It's only something, how do you really implement on ground, and how do you really bring MSME or the funders together. My understanding from federal government, central government, as well as what long back when 161 municipal corporation wanted to go for street lighting, and under Mr. Haidar's leadership, we did that work. It didn't took forward primarily because there was a mistrust between or rather we could not put the contracting in place at some time.
We have a question back there. Two questions now.
Please give you the mic.
Good afternoon, everybody. I am Assistant Electrical Inspector working with the Energy Department, Mr. G. M. Bhavsar, currently posting at Vadodara. As our distinguished panelists discussed regarding the harmonics, I would like to add something, and then I would like to go straight to the question. Regarding harmonics, there are certain provisions which has been made. I would like to add in Indian Grid Code 2007, as well as in SHIA Regulations 2023rd edition, and in Gujarat Supply Code 2015. So we can go for the reference of that. and they are very equivalent to the IEEE 519-2022. So from these, I would like to ask the panelists that it is not only the energy conservation. Now the need of hour is to address the mitigation of harmonics, because harmonics is a very dangerous disaster. Rather I would to say hazard. So if we do not address it properly, it may pose serious threats to our installations, sir. So apart from the basic harmonics mitigation techniques, that is the passive filters, active filters, I would like to just request that we should also think about the harmonics mitigation transformer, HMT. Thank you, sir.
So, because I pointed out that, and I think I should answer that. So, harmonics, yes. Now, when we look at the metering infrastructure, starting from AMI based infrastructure for large consumer, heavy consumers, to now rolling out smart meters to the end users, even domestic consumers, right? First of all, do we have a instrumentation logging the harmonics, at least third, fifth, seventh, may not be higher order. That is one. Now for a billing, whether it's a penalty or so, just to compensate that harmonics, why the consumer would be motivated to suppress the harmonics unless there is a regulation? Now you said regulation, but now do we have a sufficient metering infrastructure to log that time series data to extract third harmonics, fifth harmonics, seventh harmonics, so that the billing would be appropriately done, correct? Now even the smart meters you see, do we have that metering logging capability to measure 1/50th frequency, then 250 hertz frequency, and like this, right? When fundamental frequency 50 hertz. I'm not talking about even harmonic. Even interharmonics are also present. And those are the major threat to all appliances in industry and home appliances, right? All are sensitive. We are using AI-enabled refrigerator, AI-enabled washing machine for the controller purpose. But are we leveraging that benefits? No. Right? So the same goes with metering infrastructure. If we are not capable, or meaning existing metering infrastructures are not capable to log those multiple harmonics frequency, then how do I design my asset to suppress those harmonics? Whether my appliance, whether my downstream behind the meter is third harmonics dominant, fifth harmonics dominant. I think that is what I would say. But good to know that there are some preliminary or some guidelines about harmonics obligation or sort of the compensation required for a consumer.
Yes. Sir, should I add something in this?
Voltage, right? Not the current.
There is a gazette available कि डिस्ट्रीब्यूशन कोड में ये लिखा हुआ है कि आपको 3% से लाइसेंसी को देना है, लेकिन ये इम्प्लीमेंट गवर्नमेंट अथॉरिटी को करना पड़ेगा.
And is that for the HT consumer and open access consumer or even residents?
No, HT consumer.
HT consumer.
It is the distribution code for the distribution licensee.
Correct.
Like MGVCL, DGVCL.
Discom and distribution
हाँ,
licenses.
उनको 3% से करना है, तो उनको अपने कंज्यूमर को नोटिस देना होगा कि आपको अपना THDI कम करो, तो ऑटोमेटिकली THD भी कम होएगा. और अकॉर्डिंग टू ये इन्फोर्स करने के लिए गवर्नमेंट एजेंसी को इन्फोर्स करना पड़ेगा.
So that has to pass on to
There is a gazette available in distribution code.
Yes, sir. In supply code, voltage as well as current harmonics both has been mentioned. We can refer 2015 edition supply code. Voltage as well as current.
So voltage and current.
Both has been mentioned.
Yeah. I think it's already 12.
I have one question from government point of view. The government of Gujarat has made energy audit mandatory in the year 1999. Over the time, we have experienced that the response of the industry due to this mandate quite sluggish. day by day, they are not that too much optimistic about the outcome of this energy audit. So, ये energy audit government point of view say we should kept mandatory or we should some type of changes is require. We want your suggestion, inputs from your point of view, sir.
Sir, a little bit just I wanted to add, since he has raised the question on the harmonics. So, though whatever is correct, 3% is in voltage harmonics limit is there, and sir has whatever told, that is also correct. We do not have the instrumentation part. But only for the study part, we have done one study that what are the effects on the transformer losses on the THD. So what we in the laboratory, we created some, we injected some THDs to the distribution transformer and we measured the losses at various THDs. And we found that due to the THD, the losses are increasing in the order of 5 to 10%. So since the losses are increasing, naturally the temperature rise of the transformer is also increasing. So just that is the effect of the THD. That definitely the THD will increase the losses in the transformer.
Can I add to that, that even though if you look at IEEE standards and what's developing in Gujarat, even if it is in compliance, it's 5% or 3% or whatever it is, you're still wasting a lot of energy at the transformer level. So I think that with our technology, which is a new thing for everyone here to begin to understand and deal with, it's not about, oh, I have less than 3% harmonics, I'm okay. That's an equivalent of, do you like continuing to waste your money? Is really the question you're asking, because our technology is able to actually convert those harmonics, okay, and make them available from reactive power to now back to true power. That's what you guys are going to see come out as the next generation of parallel passive power quality systems, going beyond active, beyond passive, and going beyond harmonic mitigation, where we're going into harmonic recovery, because as you know, everything that's not at fundamental frequency is a waste. And so we can put that back to use and really do something even better than just trying to maintain a 3% level. But again, we're talking demand side. And by the way, one quick study, back in the US, there's a high precision CNC manufacturer of flight control systems for the defense industry, aerospace specifically in the US. We installed our technology there 20 months ago, so almost 2 years. And as we reduce the harmonics and repurpose those harmonics from our technology, they have a 100% reduction in their electrical motor controller boards burnout. 100%. So that saved this company hundreds of thousands of dollars on an annual basis by mitigating those harmonics on their actual demand side equipment. So it's a big deal, more or less, what you're talking about with THD reduction as it relates to KVA or headroom creation at the transformer level. So there's so much action there. There's so much action, and it's very exciting.
Actually, we are falling short of time. Do you have any question? So we may proceed further. So just complete within a few seconds, then we will proceed further. Sorry to interrupt, sir. Just.
See, it is a carrot and a stick as far as government is concerned. And these are the words Mr. Kumri had spoken to me when I made this question. So, and it has worked. It has worked. There are applications in 12th cycle. So, yes, we may not find any industry, ST industry, કે જેને આવા તકલીફ થઈ શકે. અત્યારે ખાસું એવું એનર્જી એફિશિયન્સીમાં ઇમ્પ્રુવમેન્ટ કરી શકે. So I think it is required. It is required.
Mandate.
મને એમ છે કે થોડુંક તમારા તરફથી પેલું પણ
એટલે ઇમ્પ્લિમેન્ટેશન પ્રોપર થવું જોઈએ. યસ, રાઈટ.
અને એનો દાખલો સારામાં સારો છે BEE ની PET સ્કીમ. PET માં more than 1500 people are taken, the main power guzzler
15 sectors now. Okay, and they are mandated, and everything is happening. Everything is happening because targets are there, T-shirts are being given, so implementation, is also there. તમારે જો એક્સટેન્શન કરવું હોય આપણી પોલિસી ગુજરાતની તો એમાં એક ઇમ્પ્લિમેન્ટેશન મારી દ્રષ્ટિએ જો કરી શકાતું હોય તો કરાવો.
Yes. Right, sir. Okay. Okay, we have taken your point of view. Okay. આપણે ઘણા લેટ છે આજના પ્રોગ્રામમાં. નાવ આઈ રિક્વેસ્ટ શ્રી A.B. ચૌધરી સર ટુ extend our gratitude and extend a mementos to Sri Naran Pindoria sir. Let's have a big applause round. Now I request Sri K.M. Patel sir to extend our gratitude and give a memento to Sri Prakash Vankani sir. Now I request Sri S.S. Saw sir to extend a memento to Sri Anil Khopkar sir. I request Sri Makwana sir to extend a memento to Sri Kirit C. Patel sir. I request Sri N.B. Shah to extend a memento to Sri Tyler D. Ross. And now I request Alpana Ben Dani to extend a memento to Sri Yash Patel.
This is perfect.
We have one special memento for you, sir. To formally conclude our program, I would like to invite Sri S.S. Shah sir for a word of thanks. Sri S.S. Shah sir.
Good afternoon, everyone. On behalf of Energy and Petrochemicals Department and Office of the Chief Electrical Inspector, it is my privilege to deliver the vote of thanks for this insightful conference on energy efficiency and audit at this first Vibrant Gujarat Regional Conference at Mehsana. We would like to express our deepest gratitude to Sri Rajan Rawal sir, Professor at CEPT Ahmedabad, for his keynote address. We thank Shri Prakash Vankani, Dr. Anil Khopkar, Shri Kirit C. Patel, Mr. Tyler, and Mr. Yash Patel for sharing their valuable expertise in their keynote short sessions. A special thanks to Dr. Naran Pindoria, sir, for expertly moderating the session and also for sharing his expertise on this said topic. We are also thankful to Ganpat, sir, and we are also thankful to all participants. Thank you all.
Thank you.
On that note, we conclude our event towards energy efficiency audit towards smarter consumption. A big thank you to all the speakers, panelists, participants for making this a successful and memorable event. We appreciate your presence and active participation. Thank you.